Hey, hi guys, welcome to our channel. So in today's video, we'll be looking into some of more additional functionalities which are associated with NumPy. So let's say NumPy np.I. What does np.I give us? Gives me a diagonal matrix of 1. If I did np.ones of 4, it will give me a array of length 4. But here it seems by default it will generate a 4 cross 4 matrix, which is a square matrix. If I had to do a 4 cross 4 filled with 1, I have to put a tuple of the shape of the array which I want, and will give me all the ones. Similarly, I have one more function which is called as np.identity of 4 will again give me diagonal matrix of 1, rest everything is 0. So this lower half is called as the lower triangular matrix. This part is called as the lower triangular matrix. This is called as the upper triangular matrix. So we have special functions also which we can use to extract the lower triangular and the upper triangular matrices, but we can look into it later. But what I want to focus on is that can we generate identity matrices with unequal number of rows and columns? Let's say 4, 3. If I do shift tab, you can see here n, and then you have just the D type. So we have identity 4, which is n already mentioned, and I have D type. So it doesn't allow you to put a shape inside it. Whereas np.I, if I do, and if I simply press here shift plus tab, you can see number of rows, m is number of columns, I believe, and so forth. So if m is none, by default, if I simply put 4 here, it will give me a 4 cross 4 matrix directly. But if I put here 4, 3, it can also generate unequal number of rows and columns and give the diagonal matrices. But you can see here, the diagonal by default starts from the upper left corner. Now, can I shift this diagonal below or above? I can simply do np.I of 4, 3, k is equal to 1. If I'm going above that particular default diagonal, I have to put 1. If I want to go below the default diagonal, if I put -1 here, if I put -2, it will go 2 times below the default diagonal. So np.I, you can generate any shape of matrices with diagonals as 1, and can shift the diagonal also. Because when we have a square matrix, number of rows and number of columns are same in case of identity, the diagonal is pretty much very straightforward, right? Corner to corner is the diagonal of a square. But when it comes unequal rows and number of columns, it becomes difficult. The default starts from upper left corner, then you can change it according to your need. So let us explore some more functions which are associated with NumPy. So np.rendInt, random.rendInt used to give us integers, right? 2,78 will give me any random integer between 2 and 78. However, there is one more function available in Python which says random.random, and it just takes in one particular argument, which is size. So if I put here 20, it will give me 20 different values. And all these values seems to lie between 0 and 1. This can be, treated as probabilities. So just like in Python, we have functions which can help us generate random numbers or random integers rather. Similarly, we have functions in Python which can help us generate random probabilities. So just like we have range function, remember we have a range function, list of range of 11. If I do, by default, it'll start from 0. If I put 1 here, it will start from 1 to 10. It will not take the last number, it will take one less than that. Similarly, I have numpy.range. Please mind you, we have single R in the spelling. 1, 11, if I put, it will give me an array between 1 and 10. The difference here is that's a list. I've converted to a list, and this is an array. The default step size here seems to be 1. Now, if I put one more argument, which is 2 here, right? Let's look at the third argument, what it is. Step size. Start point, stopping point, and step size. So as you look at the step size here, the step size increased 1, then 3, then 5, then 7, then 9. Next will come as 11, because 11 we are not going to take, so it will stop at 9. So third element here basically indicates the step size, how much you want to increase linearly. Default here is 1. We have one more function. So np.linspace. Linspace means linearly spaced. Now, if I put say 1 comma 11, you can see so many values getting generated. Okay, now let's try to understand the syntax. Same, start, stop, and what else? Num is equal to 50. Endpoint is equal to true. Endpoint is equal to true means it will take the number which is 11. But if I put end point as false, it will not take the ending number and change the spacing accordingly. And one more thing which I wanted to focus on here, that by default it will generate you 50 values between that in that range, right? So if I do length of this, by default it is 50. So you can always manipulate, right? You can always manipulate. You can make it say I need 20 numbers between 1 and 11. So here it has the capacity to generate a number between 1 and 10. So you can also probably make it, minus 11 or so. Let's see if it works. Negative numbers, fractions, decimal points, anything. If I want to generate only fractions between say 0 and 1, 20 different values, I get fractions as well. But the spacing will always be linear. It will be equal spaced. So guys, this is all for today. Looking forward to seeing the next video. In the next video, we'll cover a little bit more functions, try to explore it a bit and try to compare these functions, where these functions are different, where these functions are same. And this will help us understand the intricacies behind the data structure, which is called as NumPy arrays. So guys, thank you so much. See you in the next video.